Next, let's talk about atomic mass. What does an atom weigh? Remember floof from part 1? Well, let's explain that properly now. Now, Dalton theorized that atoms have mass, and atoms of different elements have different masses. But how do we measure something so tiny? Let's take the example of a fruit seller who forgot his weights for his scale. But he still needs a way to compare how heavy his fruits are. What does he do? Well, he has an idea. He takes a watermelon and slices it into 12 equal parts. Now he uses one piece of watermelon as his standard fruit mass unit, or FMU. If an apple feels as heavy as one watermelon slice, then the apple's mass is 1 unit or 1 FMU. If a mango feels like 2 slices, then its mass is 2 units or 2 FMU. So scientists had the same problem. They couldn't use standard weights to weigh an atom. It was far too tiny. So they decided to choose one atom to be their standard fruit, to measure other atoms. But which atom to pick? At first, they considered hydrogen, the lightest atom. But it was just too small, and being an extremely light gas, it was very tricky to measure accurately. Then they moved to oxygen, which was heavier and easier to use in chemical reactions. But oxygen came in different forms, called isotopes, and that made things messy and confusing. Finally, they found the perfect candidate, carbon 12. Carbon 12 is stable and solid, and 99% of all carbon on Earth is the C12 type. Bingo! So scientists said, let's divide the mass of a carbon 12 atom into 12 equal parts. Each part will be called 1 atomic mass unit, or 1U. Just like the fruit seller could now compare all fruits, scientists could now compare all atoms using carbon 12. Hydrogen feels as heavy as 1 slice, so it's 1U. Oxygen feels like 16 slices, so that's 16U.